question number 4, we're given the derivative function f prime, and we're asked to find, also given the f of 2 equals 3. So here we have an x equals 2, y equals 3, and we're being asked to find the y value when x is 1. So we need to generate the f function, which is the antiderivative. So we have dy by dx is equal to 3x squared plus 2x. Okay, so we're going to anti-differentiate this, so we're going to end up with the y function, which we'll call f of x, is equal to x cubed plus x squared. Don't forget the plus c. And this initial condition then allows us to solve for plus c. So we're going to plug in that initial condition, f of 2 is equal to 3. So that's going to be 2 cubed plus 2 squared plus c. There's our equation to solve for c. We end up with c is equal to 3 minus 8 minus 4, which is negative 9. So there's our c value. So now I have my f function defined. F of x is equal to x cubed plus x squared minus 9. And then we substitute in our 1 into this expression. So f of 1 is going to work out to be 1 plus 1 minus 9. That gives us a value of negative 7. So the answer is B. For number 5, you're given this function in a table. So this is often in AP Calculus, we're given information in a table. The independent variable is time, and the dependent variable is the rate in people per minute. It's important to recognize that this is a rate function. Okay, and this is our rate as a function of time. So it's like a velocity function. During the evacuation drill, people are leaving the building at r people per minute. And t is in time in minutes, and we're given selected values of r of t. So using a Wright-Riemann sum with three subdivisions, approximate the number of people who leave the building in the first 15 minutes. So first of all, we need to recognize it's a Wright-Riemann sum. So notice that as I plotted the points here, 100, 100, 75, 55, I'm going to use the right edge of the interval. So this first interval, the right edge is going to be on the right-hand side. And I'm going to use this to approximate the area under this curve. And this area then will represent the change in the number of people. So here we have, this will represent 5 by 100, so 500 people here. 5 times, and this height is 75. Okay, just maybe put that 75 in here. So 5 times 75, we end up with 375. Okay, this height here is going to be 55. So 55 times 5 gives us 275. And when I sum all that together, that sum adds up to 1150. So the answer is B. For number 6,